Okay, geometry fans, the topic for today, we're going to start the next chapter, the next unit. So this is Notes 6-1, 6-2, Properties of Parallelograms, proving that a quadrilateral is a parallelogram. So the first thing that we'll do, let me give you a little math joke. Well, actually, it's not a math joke, but it's just a joke for the day. What happened to the egg when it laughed at the joke? And the answer is, it cracked up. Okay, so talking about parallelograms, the first thing we need to do is talk about what a quadrilateral is. So basic quadrilaterals, a quadrilateral is a four-sided polygon. Four-sided polygon. So it's basically a closed figure in a plane that has four sides. Now there's four that we're going to talk about for the most part, that we're going to discuss a lot. The first one is a parallelogram, and this is the one we're going to concentrate on today. So the definition of a parallelogram, it's a quadrilateral. Okay, so we'll say quadrilateral. Quad means four. Quadrilateral with both pairs of opposite sides parallel. With both pairs of opposite sides parallel. Now, we're going to be using the symbols for parallel. The symbol is just two vertical lines up and down. Okay? The way this looks, a parallelogram is kind of like a slanted rectangle, and we'll talk about rectangle next. And when you label this, what it means to be a parallelogram, the definition is that the opposite sides, so in this case the top and the bottom, they're opposite sides, and then the left and the right, those are parallel to each other. Okay, so if I label this A, B, C, D. Now when I label any kind of quadrilateral, it doesn't matter where I start. It does not matter whether I go clockwise or counterclockwise. What does matter is that once I start to label, I keep going around until I finish. So if I start with A here and then here's B, I cannot jump across to C like this and then back to D. It's got to be A, B, keep moving around, C, D. And based on this, we can say segment AB is parallel to its opposite side, DC, and then we have AD on the left, parallel to the right side, which is BC. Okay, that's the definition of a parallelogram. All right, now a rectangle, let's move over here. A rectangle, I'm going to say quadrilateral, with four right angles. A quadrilateral with four right angles. That's the definition. Quadrilateral with four right angles. Okay, in other words, we could also say all angles congruent. All angles congruent. It's equiangular. Now I know that you know what a rectangle looks like, but let's draw one anyway. So there's a rectangle. What makes it a rectangle? By definition, it has four right angles. Okay, so if we say, let's call this thing Q, and I'll say R, I'll go this way, QRST. What it means to be a rectangle is that you have all these right angles. You can say, for example, that QR, segment QR, is perpendicular to segment RS. Perpendicular to segment RS. Now perpendicular, here's QR, here's RS. Perpendicular means they form 90 degrees. Okay, perpendicular, remember that that's 90 degrees, that's right angles. Okay, so that's a rectangle. Now, a rhombus is very similar to a parallelogram. The definition of a rhombus is a quadrilateral, so we'll say quad, with four congruent sides. Four congruent sides. In other words, it's equilateral. A rectangle is equiangular, all the angles are congruent. A rhombus, all the sides are congruent. Now you might be saying, well, that sounds a lot like a square. Well, you're actually on the right track with that. It's like a square, but it's slanted. So a rhombus would look like this. It's kind of like a diamond. All four sides are congruent. That's not a square, it's a rhombus. To have a square, you would have to know more. So if I call this, let's say this is E, F, G, H. What you can say is that segment EF is congruent to segment FG, is congruent to segment HG, is congruent to segment EH. They're all the same. That's a rhombus, and then the last one is a square. A square is basically if you take a rhombus and you take a rectangle and you put them together. It's got both of these definitions. So it has 4 right angles and it also has 4 congruent sides. So we'll say a square is a quadrilateral with all sides and angles congruent. All sides and angles congruent. So a square looks something like this. All 4 sides are congruent, and also we have 4 right angles. And there's another name for this kind of figure. If all the sides and all the angles are congruent, we say that this is regular. Regular means all sides, all angles congruent. All sides and angles congruent. Okay, so that's going to be a square. Now the thing is, all 4 of these are parallelograms. A rectangle is also a parallelogram because the opposite sides are parallel. So is the rhombus, so is the square. Now, let's talk about what makes a parallelogram special. What are some of the properties of a parallelogram? Well, the first one, we already have this, but I'll label it again. We know that the opposite sides, both pairs, are parallel. Okay, so what we'll do here, what we'll write down, number 1, on the side, is we will say both pairs, opposite sides, parallel. Opposite sides, parallel. Both pairs of opposite sides are parallel, and that means that AB is parallel to DC, and that means that AD is parallel to BC. Okay? So that's the first property, that's just the definition. Okay, now let's talk about lengths. So if I take a ruler here and I measure the sides, AB is about 5.9 centimeters and DC is 5.9 centimeters. They're the same. And if I take BC, that's about 3.8 centimeters, and DA is 3.8 centimeters. All right, so what happens here, not only are the opposite sides parallel, we're going to label them congruent, and I label that with tally marks. The arrows mean parallel, the tally marks mean congruent. So 1 mark each there, and we'll say 2 marks each here. Okay, so the second property, both pairs, I'm going to say op for opposite, opposite sides, not just parallel, but also congruent. Both pairs of opposite sides congruent. So we can say that segment AB is congruent to segment DC, and segment AD is congruent to BC. All right, so the top and the bottom, they're parallel, yes, but they're also congruent. And the left and the right side, they're opposite. They're also congruent and parallel. Now, the third property, let's talk about angle measure. If I measure, I'll do angle D. Okay, I'm going to use a protractor here. So let me line this up. Angle D, if I extend this, this goes to about 60 degrees. Okay, so angle D is about 60. Now angle B, which is the opposite angle, I'm going to turn this around. And angle B, okay, I'm going to line this up to 0, and then this would go to about 60 again. So what happens is that these are the same. So both of these are 60. And if I did angle A and angle C, they would both be 120. So what happens here, these are called opposite angles. Opposite angles are always congruent in a parallelogram. Opposite angles are congruent. So what we would say here, number 3, both pairs, opposite angles, congruent. Both pairs, opposite angles are congruent. So what we know is that angle A is congruent to angle C, and we know that angle D is congruent to angle B. All right, so opposite angles are congruent. And those are opposite, and these are opposite right here. Now the next property comes from this. What if I don't look at opposite angles? What if I look at angles next to each other? All right, so angle A, this was 120. If I travel around from angle A to angle B, that's 60. What's their relationship? Well, they add up to 180. What if I go from angle B to angle C? 60 and 120, they add up to 180. These are called consecutive angles. When I travel around, the angles they're not next to each other, but we say they're consecutive. AB, BC, CD, DA. These are consecutive angles. So the property is that consecutive angles are supplementary. I'm going to say sup. Consecutive angles, sup, and that's 180 degrees. That's always true. So as an example, what we could write down, we could say angle A plus angle B equals 180. Angle A plus angle B equals 180. You could also say, keep traveling, angle B plus angle C equals 180. They're supplementary, they add up to 180. You could also say angle C plus angle D and angle D plus angle A. All right, now the last property, so we've got opposite sides are parallel, we've got opposite sides are congruent, we've got opposite angles are congruent, both pairs, we've got consecutive angles are supplementary, and the last thing is the diagonals. Now, a diagonal in a quadrilateral is where I connect opposite points. So for example, if I connect A to C, all right, let me line that up here. That's a diagonal, AC. Okay, that right there is diagonal, D-I-A-G-O-N-A-L, diagonal, that's AC. And then I could also connect D to B, and that's the other diagonal. Now what happens here, you can show, or you can see that AC is definitely shorter than DB. Okay, so they're not congruent. However, what happens, if I measure, I'll call this point E right here. If I measure from A to E, I get about 2.6 centimeters. And if I measure from C to E, I also get 2.6. So what happens here, the diagonals, they cut each other in half. These pieces are the same, and then these pieces are the same. And if they cut each other in half, that means E is a midpoint of the diagonals. And the other way we say this is property number 5, the diagonals bisect. Diagonals bisect each other. Bisect means cut in half. And that's the end of part 1, and that's the front of the notes. These are all 5 properties. Go ahead, flip it onto the back, and we'll look at some examples.